robotic simulators and what do they actually do? Why are they used, and to what extent can they be used? I mean, it's a great tool for somebody who wants to learn, definitely, because let's say you want to practice programming aspect or something, you don't need a physical robot. I mean, can you speak a little bit more about robotic simulators?
So robotic simulators, I think they've come up. I don't know what their history was as far as the timeline is concerned, but so they basically came up as a means to test your robots, test your algorithms on your robot without actually deploying it on the physical robot. So suppose you're developing your own motion planning algorithm, that'll ensure that your robot gets from point A to point B while avoiding people and all that stuff. And it's a new algorithm and you won't know exactly how it behaves. You would want to test it out on like a simulator, so that you won't end up crashing your robot or something, or doing some damage to it. That's one of the main reasons. uh, and it is also, since machine learning has become more and more infused into robotics, it's also a means to test your machine learning control algorithms without uh, the time expense that you would have to dedicate on the actual system.
I see. So you're saying that robotic simulators are used by default before anybody programs a robot or something to test things out.
By and large, yeah.
Okay.
uh, there are some difficulties that people end up facing when you train your robot in a robotic simulator and then deploy it onto the actual robot, because your sensors, that your real life sensors will not be the same sensors that your simulator is mimicking. So there will be some discrepancy, but there are ways to handle that.
I see. So let's say if this is just a kind of an in-depth question right there, it just
Mm-hmm.
occurred to me.
Yep.
So let's say you train your robot in a simulator, and then you go on to deploy that on an actual physical robot. Can the model or whatever change because now it's suddenly getting input from the real world?
Can the model change?
The sorry, the machine learning algorithm or something, can it change? Can the robot rewrite its own algorithm or something? I don't know how this works, sorry.
uh, yes, to an extent.
Okay, okay,
Not a straightforward yes.
okay.
I think when these companies like Waymo or any of these self-driving car companies, right?
Hmm.
When they actually train their algorithm, I don't think they use any simulators. I think they use like real world sensor data, uh,
I
so
see.
that there won't be any loss or discrepancy of information.
Right.
Uh,
But I think for things like drones and all, it's safe to use uh,
from my
simulators.
personal experience, when I use these simulators and when I deploy them on the real thing, it didn't work proper
Okay,
as
okay.
expected, even after uh,
I see, I see.
augmenting them with the sensor characteristics.
So it's more for learning and training yourself without screwing up any physical
I would
robot.
say maybe you can get a baseline model with these simulators.
I see. I see. Okay.
But
I
yeah,
see.
I don't think any of these real companies would just
Or
go
maybe
ahead.
they have built their own simulator and we don't know about it because they would keep it secret.
Oh, maybe.
Yeah.
Maybe these flight simulators that pilots train on.
Exactly.
Maybe, yeah.
Exactly. Right. What about, you said in India, self-driving cars will probably not work. Please, can
Yeah.
you speak more about this? Because this is a
Sure,
huge
sure,
disappointment, right?
sure,
Like, I
sure.
don't
Yeah,
want to
yeah.
commute. So,
Yeah. Okay. So AI as control systems, right? Which is what machine learning is used in the robotics context. They are highly rules-based algorithms. Okay, they sort of implicitly generate the rules, but at the end of the day, they follow certain rules under the hood. When you have a red light here, people won't necessarily stop. Uh,
okay, so it expects the system to work properly all by itself first or something.
Yeah, yeah. And I'd say here there's a bit more chaos on the roads. So even if like that algorithm would, suppose you develop and train and build a machine learning model to deploy on your self-driving car. Given the chaotic conditions here, I'd say it would be a very conservative algorithm, and I don't know.
You think no algorithm can be trained to self-drive in India?
It could be. I'm just guessing. These are some of my initial thoughts, but
I see.
maybe on the rural side and all that.
Okay, maybe in close communities. Now there are so many gated
Yes,
communities and
yep,
all that,
yep,
right?
yep.
So, any thoughts on how terrain matters? Does terrain matter? Is it a important thing for autonomous vehicles, or is it just the route or something?
Are you talking about self-driving cars in particular, or
Yeah, I mean, yeah. Let's say let's say rules are being followed, but we still have so many potholes, right?
Yep.
And bumps.
Yep.
The bumps which are not even marked with any paint or any reflector or anything.
Yep.
Does that disrupt any algorithm and things don't work properly?
I wouldn't say it would disrupt it. Well, there could be a possible source of disruption. If the car runs over the pothole too fast, and then one of the sensors ends up breaking, then yes, that is a scenario. But other than that, no, that's just a mechanical design point of view. But other than that, coming to the machine learning part, yes, your algorithm should take into consideration what happens with the pothole, because you wouldn't want to avoid the pothole and hit your fellow commuters. So that behavior should be automatically should be evolved in the ML algorithm.
I see. Okay, that's very interesting. So all this is computer vision itself, right? Like there's no other kind of machine learning used.
So I would say computer vision is involved, but I would also say I'm not exactly sure what goes on under the hood of a self-driving car, but I would suspect that reinforcement learning is also there.
Okay, so it's a separate part. Okay.
Yeah,
I see.
So reinforcement learning is like it's a branch of machine learning which performs well as a substitute for like normal controls. So if you have like a control problem, like if you want to control how a person walks, your reinforcement learning would be the best bet to go about it.
I see. Very interesting stuff. And with regards to all the sensor data and stuff like that, are the same sensors available across multiple systems? Like, do drones have the same kind of sensors? Do autonomous vehicles have same type of sensors, etc.?
The family of sensors that most of these robots use are the same. So they need a proximity sensor, which measures like how close objects are relative to the robot. So you can have simple sensors like your ultrasonic sensor, which are used in drones or your simple mobile robots, or you can have LiDAR sensors. LiDAR sensors are basically lasers. They're quite expensive, but they're very accurate. So they are used as proximity sensors in self-driving cars. Then you also have like your localization sensors, because your robot needs to know where it is, right?
Right.
This can be a GPS, or there are other ways to do this, because suppose you're deploying like a UAV in like a burning building for search and rescue operations, you cannot rely on your GPS.
I see. Why is that? Okay.
Yeah, if you're in like not necessarily a building, but if you're in a cave or an area where GPS is not available, right?
I see.
You need to rely on other sensors to tell the robot where it is in its environment.
Okay.
In fact, that the problem of knowing where the robot is in an unknown environment is like an active area of study in robotics, and it is called SLAM, simultaneous localization and mapping.
Right. I've heard about that. Very interesting. So I'm sure, if we keep digging, there'll be more things to know and learn. And it's such a huge field, right? Like people have been working on it since decades. And we are reaching the culmination. How soon do you think we will be overcome by these robotic systems now? Like every year you hear a new hype thing coming up, Like,
Mm-hmm.
we didn't even know when these warehouse robots came, but now they are quite commonplace in the big giants, like Amazon and their warehouses.
Mm-hmm.
And India also has some warehouse robots company and stuff like that.
Yep. Yep.
So how soon do you think, the different kinds of robots will become more commonplace in our lives?
Predicting the future, I think that's always difficult, but I'd say it might be sooner than we expect. Uh, I'm not sure how long it'll take before robots take over us, but uh,
I see, I see, I
uh,
see. Yeah, we already see like these robot vacuum cleaners for the house and stuff like that, right?
yeah,
That is also autonomous vehicle itself, right?
exactly, yeah.
Okay, okay. So there are many applications, one can use this sort of thing for.
And it's also being used in underwater submarines. So
Oh,
I think
right.
yeah, when
Okay.
you have these plane crashes, right? They deploy autonomous drones, submarines.
Oh,
And so
wow.
that itself is a robot, not in the typical sense, but
Oh, so it's not human beings who go and, inspect the wreckage or something.
I'm not sure about the wreckages, but at least like I
Mm-hmm.
think when that flight crashed in Malaysia,
Mm-hmm. Mm-hmm.
I'm not exactly sure, but I think they must have used like submarines
Okay.
which were autonomous. Yeah.
So, is the principles or something different for, underwater robots versus like, ground robots or something, or aerial robots, for example, or it's just a minor thing that one has to just program for?
I wouldn't say it's a minor thing, but
Mhm.
it's just one component that changes. That is the sorry, two. The one is related to the other. That is the mechanics and the control.
I see.
So the mechanics of flight is vastly different from the mechanics of driving or going on
A
a
dive
road.
or
Yeah.
something. Okay, okay,
So
okay.
because the mechanics changes, the control architecture changes. So I'm not sure if you, I'm not sure if the audience knows of what PID control and all is. Your proportional integrative derivative controls. So these are like control algorithms that ensure that things work seamlessly in a feedback loop. So those things will change.
I see, I see. Very interesting. So that means, if you pick one specialization, you can go pretty deep into it, and there'll be much to do, because it's not like somebody just built one kind of robot and it will work in all situations. It's not like that. There's
Yeah,
a lot of
exactly.
work to be done.
Yeah.
Okay. And any comments about robots deployed on the moon or Mars or in space, for example?
Um, I think the Mars rover, I'm not, I think that was, I'm not sure about its autonomy. I don't know to what level it is autonomous, but I would suspect it is
I see.
to a
I
large
see.
extent. And another thing is, you have, this could be something in the future, space exploration with autonomous robots.
Right, right. Very insightful to have you speak about autonomous robots and what goes into building them, and what skills one needs to be able to build them. How do you get started in this? How do you, if you're interested in various things, how do you go about it? Thanks for enlightening us with all of those things. Thank you so
Sure.
much for joining us today.